So this is a video of some select problems from page 626. So select problems from page 626. This is lesson 10-2, I believe that was. So if as you're watching this video, if I'm doing problems you do not need to see, then feel free to zoom right through those if I'm doing ones that you got right. But I just picked out a few problems like you guys would have picked out if we were in class together for me to go over homework. All right, so 1/2 times the bases added times the height. The bases in this problem are 6 and 18. So that you plug those in here. 1/2, and the height of that trapezoid is 9, so you put a 9 right there. Half of 24 times 9, and that's 12 times 9, which is 90, and 18, which is 108. 108, this was measured in feet squared. So if you don't like the way it's facing, you can always turn your paper that way. Bases are 6 and 18. Height is 9. Okay, number 15. These are just a few I picked out from homework. So this one, they didn't draw you a picture, but they described it for you. It's a trapezoid. So 1/2 bases added times the height. And the bases they gave us are 2 and 3. The height is 1/3. I would add those in parentheses first. So 1/2 times 5 times 1/3. So this looks like this. 1/2 times 5/1 times 1/3. So you can just multiply all the tops. You get 5. Multiply all the bottoms. You get 6. The answer is 5/6. 5/6. Let's see, what was this measured in? I didn't write down what it's measured in. Oh yeah, I did. Feet squared. You can have an ugly answer like that. That's okay. Okay, this one. 1/2 bases added times height. This time we were not given this whole base, but we can grab that 6 right there and we can slide it over and put the 6 right here. That makes a 9. The bases are 6 and 9, and the height is unknown in this problem. But that right there is a 3, 4, 5 right triangle. This height is 4. We talked about this, if you did not memorize the Pythagorean triples or didn't recognize that that's a 3, 4, 5, you would go 3 squared plus x squared equals 5 squared. And when you take the 25 minus 9, that gives you the 16. And then when you square, you get 4. So you would just do a little Pythagorean theorem work to get that. This is half of 15 times 4. Half of 4 is 2, times 15 is 30. This is 30 feet squared. I picked out number 25. Number 25 is a rhombus. The rhombus formula is 1/2 diagonal 1, diagonal 2. One diagonal they gave us, that would be 6. The other diagonal is missing. In fact, they didn't even draw it in there. That 6 just got split because the diagonals of a rhombus, like any parallelogram, bisect each other. So, oops, that's a 3 and a 3. That's how that 6 got split. This is now a 3, 4, 5 right triangle, so this is 4. That whole diagonal is 8. And so half of 6 is 3, and 3 times 8 is 24. 24, let's see, did they give us units? Meters squared. Okay, no, I picked out number 29. 29 is the first one, I believe, in the whole section where you have to do the Pythagorean theorem to get this unknown height. So formula is still bases added times the height. And the bases are 3 and 5, because that's a 4 and a 1. So 1/2, 3 plus 5. The height is what's unknown. And so if you look at this right triangle right here, that's a 1 and that's a 3. So this is not any of those Pythagorean triples. 1 squared plus x squared equals 3 squared. 1 plus x squared equals 9. Subtract 1, you get 8. X squared equals 8. Square root, x is the square root of 8. And that breaks down to be 2 radical 2. That's what square root of 8 is. And I'll real quick show you that work. Oops, I have that kind of paper that has a... This is why I don't buy fancy paper. Let's see, 2 goes in there 4 times, 2 goes in there 2 times. So there's twin 2's right there. That's why I brought out a 2. That 2 stays in, that's why there's a 2 in. So the height is 2 radical 2. So half of 8 times 2 radical 2. And you get 4 times 2, which is 8 radical 2. 8 radical 2, let's see, what was this measured in? Centimeters squared. If you don't like that answer, or if the problem said around, you could punch that in a calculator. Number 31. Okay, here's a formula. 1/2. Remember, the formula drives the problem. See, if you're just looking at a question, you might find stuff there that you don't need to find. The formula tells you what you need to find. So the bases were given. This base is 0.9. This base is 2.1. The thing that's missing is this height right here. All right, so let's find the height. If this is 0.9, then this is 0.9 right here. And if the whole thing is 2.1, that makes this a 1.2. Because 1.2 plus 0.9 is 2.1. And so if it's, that's this distance right here, from here to here. That is a 45, 45, 90 right triangle. So if this is 1.2, then so is this. This is also 1.2. So this 1.7 right there, we don't need it. What that 1.7 is 1.2 radical 2. That's where they're getting that 1.7, but we don't need it. We need this height. So 1.2. And this gives you 3, so it's 1/2 times 3 times 1.2. Since we've got decimals in the problem, then we might as well write our answer as a decimal. Half of 3 is 1.5. 1.5 times 1.2 is 1.8. And that was measured in meters. Meters squared. 1.5 times 1.2. Okay, number 35. I picked that one. So it is a kite problem. It's kind of a short, squatty kite. This is 1/2 diagonal 1, diagonal 2. 1/2. We don't have any of the diagonals. Not either one of them. So we have some work to do to get diagonals. This is a 45, 45, 90 right triangle here, because in a kite, the diagonals are perpendicular. And if this is 9 radical 2, then the legs are 9 and 9. And so that just gave us the diagonals. This is the diagonal that's split in half in a kite. Remember, one of them is split in half and one of them is not. So that one's 18. And this diagonal is 15. So this diagonal was a 9 and a 9. This diagonal was a 9 and a 6. And so half of 18 is 9, and 9 times 15 is 90 and 45, which is 135. And this was meters squared. Okay, here's a rhombus one. Same formula. 1/2 diagonal 1, diagonal 2. 1/2. In a rhombus, both of them are cut in half. So if that's 8, so is this. That would be 16. I don't have this other diagonal, but I have myself a 30, 60, 90 right triangle. This must be 60. Okay, this is one of those harder 30, 60, 90 right triangles. because I was not given the a side that's across from the 30. I was given the a radical 3 side. So this problem is kind of gross. We have the a radical 3 side is a normal number 8. Okay, so here's what you do. You take that number and you divide it by the radical that it's supposed to have. So you divide it by 3. That's why this one's kind of gross. It's 8 divided by 3. I'm just going to write it 8/3. And then you stick the radical 3 on it, and that's how long a is. So if this is 8/3 radical 3, and this is 8/3 radical 3, together they are 16/3 radical 3. That's how long that diagonal is. 16/3 radical 3. So let me show you that again. That is supposed to have a radical 3 and it doesn't. So you divide it by 3, that's why I got 8/3, and then you stick the radical 3 on it. And that's how long this is, this short leg, and then we had to double it. So we got 16/3 radical 3. That's how long that is. So half of 16 is 8, and 8/1 times 16/3, 16 times 8 is 128/3 radical 3. That's your answer. It's just disgusting. I'm not sure what that was measured in, but whatever units it is, that would be units squared. Okay, I picked 2 more. Number 41. Okay, number 41 said draw a trapezoid, name its bases, base 1 and base 2, name the height h, and then it said divide it into triangles and find the areas of those 2 triangles. Well, this triangle, base 1 would be the base, and the height of the trapezoid is also the height of that triangle, because here's the triangle right here. So the height of the trapezoid is also how tall that triangle is. So that triangle is 1/2 base 1 times h. And then this triangle, base 2 is the base of the triangle. The height is still the height of that same height of the trapezoid. So this one is 1/2 of base 2 times the height. Well, if you add those 2 together, this is what they're trying to get at. They're trying to show you how the formula for a trapezoid was derived. If you add those together, you get this. And since they both have a 1/2 and they both have an h, you can factor out a half and an h. And that's going to leave, like if you factored out this 1/2 and this h, that leaves b1. And if you factored out this 1/2 and this h, that leaves b2. b2. So this is how they figured out the formula for a trapezoid, is they added the 2 triangles together. They divided trapezoids into triangles and added the 2 triangles. And then they just factored. All right, last one, 45. It says the area, this is the last one I chose to do. The area of a kite is 120, one diagonal is 20. So the area of a kite is 1/2 diagonal 1 diagonal 2. They're giving me the area. It goes there. They're giving me one diagonal is 20. And they want the other diagonal. So this is what it looks like when you get everything plugged in. 120 equals 1/2 of 20 is 10. 10 times diagonal 2. And divide both sides by 10, and you get the diagonal 2 is 12. So it's just an example of using the formula kind of backwards, where they give you area and you're looking for some other value. All right, those are the problems that I chose to do from that homework. I hope that helps. And again, y'all have a great day.